so to kind of like kick this off then, talking about simplifying these trig expressions, all right, we're going to look at kind of identifying or like the origin of one of them at least. So we already know some like things that are going to be helpful to us here. So for example, we know that sine of x, for example, is equal to 1 over what other trig function here? Sine of x is the reciprocal of what trig function? Cosecant. That's right, cosecant x. Very good, right? And so we also okay, cosine of x, then that's equal to the reciprocal of secant. All right, and then tangent of x is equal to the reciprocal of cotangent. Okay, so that's helpful. And then, you know, by kind of a similar relationship here, cosecant of x reciprocal, or sorry, 1 over cosecant of x equal to 1 over sine of x, right? By the same kind of idea here, secant of x is equal to 1 over the cosine of x, and cotangent of x is equal to 1 over the tangent of x. Okay. Now, there are some other things, there are some other kind of trig identities that we want to be familiar with, some relationships between these different trig functions. And we're going to kind of examine those relationships using a right triangle to kind of help guide us, and the Pythagorean theorem as well. So let's start with a right triangle here, and I'll start with an angle theta in it, and then I'll just label some parts here. So let's say that's A, that's B, and that's C. Okay, using kind of the traditional Pythagorean theorem stuff. Right? So given with the way this is set up, right, if I were to say sine of theta, that's going to equal the ratio of what two sides here? What two sides will that, what ratio of what two sides will this sine of theta equal here? Yeah, Cassie. A over C, right, how'd you know that? Right, opposite of angle theta is A, the hypotenuse is C. So sine of theta has got to be A over C in this situation, right? Opposite side, opposite leg over hypotenuse. Okay, right? Likewise as well, right, the cosine of theta will then be what? Anybody? B over C. Again, the adjacent leg over the hypotenuse. Okay. And we know the tangent of theta is equal to what? A over B, right? Opposite over the adjacent leg. So it's like, all right, Miss Way, that's obvious. Well, how is this helpful? Well, if we take, for example, if I take A over C and divide by B over C. So if I take sine of theta and divide by cosine theta here. Sine of theta divided by cosine theta. Well, that's equal to, according to our ratios, you're right, sine of theta, that's the same thing as A over C. So I can just put A over C. And then cosine of theta, according to our ratios, right, cosine theta in this situation is B over C. But of course, like in the warm-up today, we now have like fraction within a fraction kind of thing. So we want to try and rewrite this. So instead of saying A over C divided by B over C, I can write A over C times what? C over B, that's right. And now that I've rewritten it, what can we do here to simplify this? Cancel the C's, right? The C's cancel. We're left with A over B. But what does A over B equal? Tangent. So in general, tangent of theta equals the sine of theta over the cosine of theta. And I think we've already talked about that, but now you can kind of see why that relationship is so. Box these into. Okay. So if tangent of theta is sine of theta over cosine of theta, what does that mean cotangent of theta would have to equal? Tangent of theta is sine of theta over cosine theta. What would cotangent theta have to be? Yeah, cosine theta over sine theta. Exactly right. You just do the reciprocal. Okay, so again, I believe we talked about that, but just to kind of reintroduce it here. There it is. Okay. So these identities up here, these are called the reciprocal identities for obvious reasons, and you don't need to remember that. I'm not going to recite all the reciprocal identities, but just so you know, these are called the reciprocal identities. These are also identities too. I don't know what the names for these are. I'll try and look it up here in a second, but I don't know what the names of those are. But those are also identities, right? Because we're saying tangent of theta is equal or is the same as sine theta over cosine theta, and here cotangent theta is cosine theta over sine theta. Again, those are identities. They're equal to one another. Okay, and then I have one more identity that I want to derive here, and it's going to, again, use the sine, cosine, and tangent relationships here, and then we're going to also throw in the Pythagorean Theorem. So, we also know that the Pythagorean Theorem states that if you have a right triangle, then the leg squared plus the other leg squared has to equal the hypotenuse squared. Alright, so one more identity here we're going to kind of derive. Alright, so in this triangle, right, this relationship must hold true because we have a right triangle. Pythagorean theorem must hold true. Additionally, though, right, we also have that sine of theta is equal to A over C, and we have, for example, the cosine theta is equal to B over C. So we have those relationships as well. We're just going to pull those out. We'll ignore the tangent ones right now. We'll just have those relationships. Why is that useful? Well, that means if sine of theta equals A over C, then that means A is going to equal C times the sine of theta. And cosine theta equal to B over C means that B must equal C times cosine theta. Right? All I did there was just multiply both sides by C, multiply both sides by C to get the kind of A and the B by themselves there, right? We solved this little equation here for A and B. It's kind of weird, right? We haven't really done that, but that's something we can do, right? It's mathematically equivalent. And now this A and this B are the same as this A and this B right here, okay? This A here, this A here, this B here, they're the same as those A's and B's. So, instead of writing the Pythagorean theorem this way, we could use, instead of A, I could write C times the sine of theta squared plus C times the cosine theta for B, again, quantity squared, equals C squared. So now if I square C times sine of theta, what gets squared in here? What gets squared? When I square this product, what things get squared here? What's going to get squared here? What does this simplify to be? When I have the quantity C times sine theta squared, what does that simplify to be? What does it become? C squared times
C sine of theta.
close. So you square the C already, so we just need to square the sine. So the sine squared theta. What's that?
I thought it was like FOIL.
Nope, no need to. A FOIL if it was addition. If it was C plus sine theta and squaring it, then yes. But C times sine theta, it's just like if you had, 2x and you square 2x. Well, you could think of it this way. It's 2x times 2x, which is just 4x squared. So what did you really do? You just squared the 2, you squared the x. Same idea. When you have a product and you square it, that's the easier way to do it. You don't need to FOIL it. It's just squaring individual pieces. Okay, so then by that same kind of thing, we say it's C cosine theta quantity squared is C squared cosine squared theta equals that C squared then. Okay? Now, what can we do here to simplify this? What can we do? Yeah, Melissa? Yeah, divide both sides by c squared. Each term here has a c squared, so divide both sides by c squared. Okay, and so those c squareds are going to all cancel, right? We're going to end up with, well, I guess we can break it up to c squared sine theta over c squared plus c squared cosine, ooh, goodness, getting ahead of myself, cosine squared theta over c squared equals then the 1, and then these c squareds cancel. I forgot my square. Okay, and so we end up with another identity. Okay, we end up with another identity. In this case, all right, it's sine squared of theta plus cosine squared of theta will always equal 1. Okay, sine squared theta plus cosine squared theta equals 1. That's just from kind of playing around with the definition of sine and cosine and the definition of the Pythagorean theorem, and using those two related components to put them together and come up with this identity here. So sine squared of an angle theta plus cosine squared of that same angle theta will always equal 1. Always equals 1. Okay? And you can kind of see that in our unit circle. If you pick any coordinate, on the unit circle, right, the x coordinate there is the value of cosine at that angle, and the y coordinate is the value of sine at that angle. And if you take that x coordinate and square it, and you take that y coordinate and square it, you're going to end up with 1. Right? You're going to end up with 1. So there's that identity. And from that follows some other identities. So if we take, for example, the sine squared of theta plus cosine squared of theta equals 1. And if we manipulate this by like dividing both sides by sine squared of theta, so you kind of like divide through by sine squared of theta. Okay. These simplify to just be 1. Right? Sine squared divided by sine squared is just 1. Cosine squared theta over sine squared of theta, what's that going to be? What can we say that is? Not cosecant. Cotangent, right? Remember we just said cosine over sine is cotangent, so therefore cosine squared over sine squared would be cotangent squared. But then 1 over sine squared, what's that going to be? That's the cosecant squared. Theta. And then the third of these identities is if we take that original sine squared theta plus cosine squared theta equals 1, and we divide through not by sine squared but by cosine squared. Okay, so we divide it by cosine squared. Sine squared divided by cosine squared, we can rewrite that as, or what is that same as? Tangent squared. Okay, cosine squared divided by cosine squared is 1, right? And then 1 over cosine squared is secant squared theta. Okay, so this, and this, these are all known as the Pythagorean identities. Okay, Pythagorean identities derived from Pythagorean theorem. Okay, and the definition of sine and cosine. Okay. All right, so should, you run across a sine squared plus cosine squared in some situation, you can just go ahead and say, oh, it's just 1. That's root of 1. Okay. And these can be manipulated too, right? So I could like subtract the cosine squared over, and we could say that sine squared is equal to 1 minus the cosine squared. Kind of thing stuff too. So you can manipulate these around a little bit. It doesn't always have to be sine squared plus cosine squared. If you take that, and I'll just go ahead and do a quick example up here, maybe in my little, just like a little aside here. If I have that. If I have like that, right, then that means the same. That means like cosine squared theta. Then if I just see a cosine squared theta by itself, that means it's equal to 1 minus the sine squared of theta, and vice versa. I could subtract sine squared from both sides, and the relationship would still hold true. So stuff like that. I could say like that sine squared is equal to 1 minus cosine squared. Stuff like that. Okay. So there's all those identities, right? Reciprocal identities, tangent and cotangent, just their definitions, I guess, of their relationships. Okay, those identities. And we also have the Pythagorean identities, the 3 Pythagorean identities. Okay? So, how are we going to use these? Well, all right, our goal here is to take these identities and then use them to simplify trigonometric expressions. So, let's go ahead and do some examples here. So, okay, so let's start with something like cotangent of x times the sine of x. Okay, cotangent of x times the sine of x. So we won't use thetas here, we'll just use an x. Same idea. Okay. So, right now we can't multiply those two things together. They're not like, right? We have cotangent of x times sine of x there, so it's not really good. But we do know that cotangent of x, one thing we know about cotangent of x, it's equal to 1 over tangent. So I could rewrite cotangent of x here. I could say, okay, this is equal to 1 over tangent of x times the sine of x. But if I look at that, it's not very helpful. Right? Sine doesn't cancel out with tangent any more easy than it does with cotangent, so that's not really a way we want to go. But what's another thing we know that cotangent is equal to? Yep. Cosine over sine. So now, if I kind of put this thing here, I could rewrite that cotangent as cosine x over sine x times sine x. And then what can we do now that we've done that? Devin, what's the point of that? How's it helpful? Yeah, so sine of x by itself is just really sine of x over 1. And yes, we have a sine in the numerator, sine in the denominator. They cancel. So we're left with just cosine x. Okay? And that's about as simple as we can make it, right? Not much simpler than that. So that's about as simple as we can make it. Cosine x. That's it. Okay? Let's try another one here. Let's try. Let me see. I'll put that back down here. Okay. I'll be jumping a little bit more ahead than I wanted to, but we'll see. Okay. So this one's a bit weird. So we have sine x times cosine squared x minus sine of x. Okay, so we can't subtract because we don't have a cosine squared. These aren't like terms, right? They both have a sine, but they both do not have a cosine squared, so they're not like terms. You can't just subtract them straight up. Okay, simplify this. So, what could we maybe do here? Any ideas? Any ideas? Yeah? Great. Okay, so, good question, right? This, we, in an equation setting, we would have, like, if we had an equals to something over here, we could add sine of x to both sides. The problem is, though, this is not an equation. We don't have it. We don't know what it's equal to. So we can't just like throw in an equals 0 here. We don't know that's the case. We're just trying to simplify this. And so yeah, we don't have another side that we can kind of add to here. We just want to try and simplify this right here. So we don't have another side to add to. So good thinking, right? We would want to be able to add the sine x over divide, but unfortunately we don't have another side. There's no equation here. We're just trying to simplify this. So again, the question remains then, what can we do here? Any ideas? Both terms have a sine of x, so what would that allow us to do? Yeah, Nick?
Could you change cosine squared of x to 1 minus sine squared of x?
Yes, we could do that. So let's see how that goes. Sine of x times 1 minus sine squared of x. Okay, so first of all, where'd you get this? How did you know that cosine squared is the same thing as 1 minus sine squared?
Sine squared of x plus cosine squared of x equals 1.
Right, it's our Pythagorean identity here. So when we see cosine squared, that's equal to 1 minus the sine squared there. That's right. Okay, so let's see what we can do here. So now that I have that written, what can we do? I have a sign in front of parentheses there, so what can we do with that sign? I could distribute it, right? So I have sine x then, and then minus, sine of x times sine squared of x. What's that? What's that? Sine cubed, yeah, sine cubed, yeah. Minus sine of x. Okay. Can we simplify any more here? Can we simplify any more here? Yeah, okay, we have a sine, positive sine of x, and then minus the sine of x. They cancel. And so we're left with just negative sine cubed of x. And then that's as simple as we can basically make it there, as far as we can go. So simplifying here, right? Simplifying is that nebulous term, right? It means a lot of different things in a lot of different situations, especially especially in math, right? We have different things we need to do here. So how do we know we've simplified here? Well, again, what makes us feel we simplified it? For example, at number 1, we had two trig functions, and it became one trig function. Here at number 2, we had kind of one term minus another term, and again we were able to combine those or manipulate things around, so we end up with just kind of one term. So visually we can kind of see it's simplified, right? So sometimes we might be like, well, is it simplified enough? Like, could we do more here? In this case, the answer is no. There's no other thing we can really do there. Okay, but it can be kind of tricky to figure out what to do. All right. And sometimes there's more than one way to go about solving these too. So, if you are doing your work and you look next to your neighbor and you're like, oh, what are they doing? And then you see something different, that could still be the case, and you still could both end up with the same answer as well. So don't fret too much about that if you end up with like different, kind of problems and stuff like that, because that is, a thing. It happens. You do it different ways, but you can end up with the same thing. All right, let's try another one here. Let's try. Okay. How about cosecant of theta divided by cotangent of theta? Cosecant of theta divided by cotangent of theta. All right, so you've got division, but they're not like, so you just can't cancel things out. So any ideas here about how we should approach this? Well, Devin?
Could you make cosecant 1 over sine of theta?
Okay, so cosecant is now 1 over sine of theta.
And cotangent, cosine over sine.
Okay, so we'll put over then cosine theta over sine theta, like that. Okay. So first of all, I just want to make sure everyone's okay with that, right there, what Devin did, right? We took that cosecant theta, which we know is equal to the reciprocal identity 1 over sine theta. And cotangent theta, that's just by definition cosine theta over sine theta. Okay? I think it's called a quotient identity. I looked it up, if you're interested. Not that you need to have those names down or anything like that, but that is called the quotient identity, is the those two identities. Anyway, sorry, go ahead, Devin. I apologize for interrupting. What can we do now?
Multiply by the
Yeah, so 1 over sine theta, then instead of divided by cosine over sine, is now times sine theta over cosine theta. Okay, and then what? Cancel the sine thetas. And so we have 1 over cosine theta. Okay. And there's like one more thing we could say here. What's 1 over cosine? Secant. So we could say that really the final answer is secant theta. Okay. And there it is. There it is. All right. Anyone see that in a different way? Anyone think about doing it in a different way? All right, I'll just show you one other quick thing here. One other option. So that's the way I probably would have done it there, but just so you can see, cosecant of theta over cotangent theta, an alternative there is you could have said, okay, well that's cosecant theta times 1 over the cotangent of theta. Board of Education? Good day to you.
Just in case they need help.
Oh, gotcha. Very good. All right. So 1 over cotangent theta, that's tangent theta. Right? And then you can rewrite everything in terms of sine and cosine. So 1 over cosecant, or cosecant theta is 1 over sine theta. Tangent theta is sine theta over cosine theta. And again, the sines will cancel, and so you're left with 1 over cosine, which is then just secant. So you can see that there's more than one way to do these problems. 2 different paths take, but you end up with the same result, as long as you're doing, it's correct. All right. Are we ready to try one on our own here? Alright, I didn't hear a resounding no, so I'm going to do it. Here we go. So, let's see. I'm going to have you all try. Oh, and I don't want to do all these. Alright. Cosine theta times tangent theta over sine of theta. Okay, go ahead and simplify that. Let's go ahead and try that one. So I recommend only memorizing this one, and you can derive these other 2 by dividing by times square dividing by cosine. But yes. So dividing by sine is not the same as multiplying by sine. Wait a minute. Okay. So. Back up. First of all, tangent theta. That's cosine theta. Right, and the way I remember it is cotangent equals cosine over sine. That kind of helps me understand sine over cosine. So there's that, right? Okay, so now what? And that's right, 1 over. Close. I think so. So you want to multiply these two things, you say? So not quite, because this is a numerator, this is a denominator. So you don't want to multiply those two things. But let's take care of this, right? Because you have a fraction and a fraction. So taking this fraction and dividing by sine of theta is the same thing as taking this fraction and multiplying by 1 over sine of theta. Right? So rewrite it that way. Take care of that, like, fraction and a fraction kind of deal there. Alright, what's up? Okay, don't forget to say cosine theta. No, but you have this cosine theta here. That's what I'm saying, though. Right? You have the cosine theta here, you have the cosine theta here. Right? So you took this. Okay. Right, so what I'm saying, you took this piece and rewrote it this. And then you said it applies to sine theta cosine theta. Well, this applies to this. Whatever cosine theta, right? So this piece applies to 1 over cosine theta. Just this. Right? But you still have the cosine theta here. Right, because it's 1 over cosine theta. So this piece applies to 1 over the cosine theta. So that should be a 1 if you want cosine theta. Right? So yes. Yes, we need to change it to 1 over here. Yeah. Yes, I guess so. You multiply when you write this, you multiply by 1 over sine theta to 1 over sine theta. Because like this, I'm not sure. Like this is not quite mathematically equivalent to this because you brought up this. I'm not sure what you're doing. So you're changing over sine theta to this to 1 over sine theta. Okay. Yeah. So yes, from here to here, that's fine. Yes. Gotcha. Okay. Yes. Good. Yes. Yes. Right. Good. Stuck. Okay. All right. So dividing by sine of theta, it's not going to be a cross multiply situation here because we only cross multiply when we have an equal sign. It's like when it's a proportion. So it's still going to be, well, let's go back to this. My recommendation changes to sine over cosine. Okay, and then you have a fraction and a fraction kind of thing, and then rewrite it. Okay, rewrite it so you know a fraction and a fraction. Because divide by something, multiply by something. Not sure? So don't get cosecant, leave it in terms of sine. Right? So that's still 1 over sine, right? Because divided by sine is multiplied by 1 over sine. Okay, and don't forget your theta. Okay. And now it's all one big product, right? So you don't really need it. So you will simplify, right? Good. Yeah, good. Okay, so remember, this goes in the denominator. So this is equal to 1 over cosine theta. Right, 1 over. And behind cosine theta, so this is 5 there. Yes, good. So far, so good. Then what? Well, how do you multiply these two things together, right? We make it a fraction. Cosine theta is really cosine theta over 1. It's not cross multiply, you multiply across the top. Cosine theta times 1 is cosine theta, and then the 1 times cosine theta is cosine theta. Which is? That's what? Okay. That's a good start. Yes, I would suggest. All right, we'll talk about this. All right, let's take a look here now. All right, so here's what you should end up with. 1. Okay, so a good strategy to use here, my recommendation, if you'll notice, for a lot of these, right, we were taking, for example, we had cotangent. Yeah, we rewrote it as 1 over tangent. You could do that, but really it was more helpful when we converted that cotangent to cosine over sine. Right? Here it was already in terms of sine and cosine, so we were able to simplify it down. Here, in number 3, right, we rewrote cosecant and cotangent in terms of sine and cosine, and we were able to cancel things out. Here again, in number 4, we had tangent. We rewrote that in terms of sine and cosine, and we were able to manipulate and cancel things out to get 1. So, a key kind of thing to help you is to rewrite in terms of sine and cosine. Every trig function can be rewritten in terms of sine and cosine, and then this will help to kind of like put things in common, terms so that it can cancel and stuff like that. All right, so just to run through this here real quick, doing that here, we have cosine times tangent over sine. Tangent, right? We know it's the same thing as sine over cosine. Okay, but that's still over the sine there. All right, so Ellie, does that make sense? Going from here. Here, I don't want to call you out, but anyway, thank you for being. I'm sure there are others that had trouble, but I saw that you. Okay. So, tangent is sine over cosine, right? So we're good. That's still over the sine, though. Okay. Dividing by something is the same thing as multiplying by the reciprocal. So sine theta over cosine theta, instead of divided by sine theta, we'll multiply by 1 over sine theta. Right? And now, sine theta in the numerator, sine theta in the denominator. Cosine theta in the numerator, cosine theta in the denominator. And so they all cancel. We're left with just 1. Okay. All right. I'll give you guys some practice then for this. So that's it. All there is for today. So we'll have you guys get started on the homework here and get you some practice. Because I think that's really where we're gonna get this down. Okay. Again, there will be a quiz on this on Monday. I know Monday quizzes, yuck. But again, it will be a partner quiz. You may work together. The partner quiz, yes, we'll cover this and what we're doing tomorrow, which is basically just verifying things tomorrow. So yes, this will be on the partner quiz. Okay. Notice there's no odds here. I'm not saying the word odds here. I want you to do all of them from 25 to 28. Okay. 25 to 28, all of these. All right. Do you have any questions? Yes.